So this is Math 1127, section 7.4, hypothesis test for proportion. Now, this is very similar to before. In the past, we checked the hypothesis test for the mean, for the average. Like, is your average age or mean age bigger than 5 or less than 5 in a daycare, for example? For proportion, it's more like kind of the coronavirus we have right now is that how many percentage of people has the virus. So you can construct a test, and before we construct a confidence interval, right? Basically saying, hey, let's just say the White House say we have less than 5% of people with coronavirus. Then you can test. You can go and look at the data and see whether or not their hypothesis, whatever claim they're making, is backed by evidence. So really the difference is between average and proportion, but everything else is the same. Now the way we do it is first, let me just show you. You go to stat, go to test, and you want to do one proportion z test. We are always going to do z in this class because we're gonna have enough evidence, enough sample size for all this. We're not going to do two proportions. So enter. So this is something we're going to put up, right? So first, let's look at the first problem here. Example 7.4.9t. Now let's see what we got. They say a medical researcher says that less than 23% of the adults are smokers. So here's how you would construct the null hypothesis. It's the same thing, except instead of mu, we're going to use p because we do the proportion. Oh, let's do the hypothesis first. Null hypothesis is p. So the claim is less than 23%. So the opposite would be what? Bigger than or equal to 0.23, right? So let me do the second one. So let's say there's an alternative, and this is less than, and this is the claim. Less than 23% of the country are smokers. So now, in a random sample, 200 adults from this guy. So it's like, I don't let's just talk about the kind of like the coronavirus, right? If somebody say we have less than 23% of people who will test positive, right? In theory, in this random sample, they picked 200 people. So you can say this. They basically say n equals little sign equals 200. I went and I basically sample statistics. We sample 200 people, and then out of those 200 people, we have 17% who say they're smokers. So I would say that's P. Usually for that, we have a different way to call it. Let me show you. We call it this. Right here. We'll just call it P with the hat. Is equal to 0.17. So that's the kind of like the sample proportion. And of course the level of significance. How do you spell significance? Right. That safe driver say 40%. It is. That safe driver say 40%. It's right there. It's here. It's right here. Oh, I forgot to see. Equals is alpha equals 0.05. So now, same thing. Let's just go to the calculator. What's the P? Not the P0. P0 is just this guy, the original P. So 0. 0.25. 0.25 or 23. There you go. And what's the x? X is the number of p. So let's do n first. N is the total, right? 200, right? What's the x? X is how many people who belong to that category. So X is how many people who are smokers. Now they say 17% out of the 200 are smokers, right? So I'm using a different calculator. I know that's kind of stupid, but whatever. So 200 times 0.17. That's 34. So I should say this. X equals to 34. So your calculator will accept that number and not the percentage. It will basically calculate percentage on their own. So instead, there's a left tail test. Enter. Calculate. So there you go. So let's see. We have the test Z test statistic is equal to negative 2.02, and then the p-value is what is it, 0.022. Don't worry about the 0.17 right here. That's basically this guy that they gave us. Right? So it doesn't really matter. So what is the claim? The claim is less than 23% of those are smokers. So this is just what we did a second ago. So let's just answer that. I need to maybe I need to make this bigger. So that's greater than or equal to, and this is less than, and that's 0.23. And what's the critical value? Now the critical value, you're gonna go back to that PowerPoint again. So I'm in that presentation, that formula sheets again, the PDF. So in our case, it's a Z statistic. So you're gonna go all the way to the bottom, which is this part right here, right, infinity. Okay. So let's go up. The level significance was what 0.05. So 0.05 is a one-tail test. 0.05 one tail. Go all the way to the bottom is 1.645. So it's 1.645. Wait a minute. For exclusive content, go to Apple TV. I want to know the reason why you don't trust him, because I haven't heard anything yet that makes it. This brother is suspect. 3 decimal places. Right? This man claims he loves me like he does. Oh, because I forgot. Because it's less than. Since it's less than, it's a left tail test, right? That's right, less than. So left tail means it has to be negative. My fault. There you go. So what are the rejection region? Meaning anything to the left, because it's left tail, of 1.645. Or negative. I keep forgetting. There you go. And then what's the test statistic? We had what was it? Negative 2.02. Negative 2.02. So look at this, right? Since the p-value, right, is less than a, right? Anytime it's less than, that means you would reject the null hypothesis. Therefore, in this case, because the claim is the alternative, there is sufficient evidence to support the claim. So let's see. Claim will reject no hypothesis, and there is enough evidence at 5% left significance to support the researcher's claim. That is less than 23% of adults in that country. Not all adults, not in the world. Check. So, almost the same thing, just a different test. So, I'm gonna go ahead and skip to the last one because they're all pretty much the same thing. I just want to kind of show you just one more example. So the next example is 7.4.17. So this one is gonna be, let's say we have the result. You interview 50 people. The result is 42% adults say they're more likely to buy a product when they have free samples. At this level of significance, can you reject the claim that at least 52% are likely to purchase an item, right, when they are free samples? So right from the get-go, right, you can already say that. Let me just go ahead and copy these. We know that the hypothesis is going to be at least 52%, and also the other one, and also the opposite too. So it was at least means bigger than or equal to. So let's go equation bigger than or equal to. So P is bigger than or equal to 0.52. Yeah, so that's what we got so far. Then the opposite to that would be less than, right? 0.52, right? Now instead the claim, nope, the claim is the other one. The claim is this one. So now let's say sample statistic. That's what we got. We have you survey 50 people, and we have 42%. 42% shows that. So 42% of that would be what? Let's see.
Why are you using the computer? But I was using it.
Okay. I'll let you use a little bit. So my daughter's out here. So 50 times
What? There's no
0.42. So that's 21. So 21 here.
I want to watch the computer.
You can look at this first, and then
No.
so let's put all this into the calculator. Hypothesis test.
But I was just checking.
And we're doing proportion.
I was just checking everyone. I was just checking everyone.
So the proportion is, let's see.
But I was checking
0.52.
When you don't talk.
This is 21. The sample size is 50. And this is less than. Okay, calculate. So what we got is, let's see. The test statistic would be negative 1.42. And the p-value would be 0.078. So, of course, for this guy, since p is bigger than alpha, then you can say we fail to reject the null hypothesis. There is enough evidence to support the claim. So let's go back to this. So it's a greater than and less than 52. There you go. That's this one. The critical value. So again, I know this is like annoying, but it's gotta, because we got a calculator that can do the work for us. So let's go to this range. The level significance is 0.05. So they'll be the same, 1.645 right here. 1.645. And this is a left tail test, right? So it's a negative. And what's the test statistic? It's negative 1.42. And you can say we fail to reject, and the data is enough proof, right? Sufficient evidence to, or to what does it say? Reject the claim. So the data do not provide enough evidence to reject the claim. So you can say this. In other words, right? In other words, not enough evidence to reject the claim. Same thing. And that's it.